So this is lecture 16. Today is Monday. So I'm just going to remind you, this test next time. No responders. But try not to look up on another browser. I'm just going to trust you all. But yes, it's going to be OpenNote. Calculator allowed. Exact answers and detailed solutions. Yes, you're supposed to upload. So I'm just going to say this, but one question per page, please. Try to put in there. What else was I going to say? So not so much in your class, but in the other class, I have that issue. Yes, Zoom as well, Jezebel. So Zoom as well. So it's going to be a live proctored on Zoom. But see, now you can have Zoom running on your desktop. Probably yes, Bhavneet. Yeah, because I got 10 minutes per question, the last 10 minutes for you to upload. So just that. What else did I want to say? Okay, I didn't have issue with you guys, but I won't accept any submissions after. And not over email this time. Because I think we have that test run and you should be able to upload it in Canvas. Any questions?
Nope.
Okay. And the other thing I'm just going to say, and I mentioned this before all of you walked in, that some of you have been asking me about next semester. So probably Monday, Wednesday, Friday classes, I would be teaching. I don't know which classes I'm actually teaching, but mostly calculus, maybe one of discrete math or whatever. But more importantly, thank you for your feedback, because they're asking us to let them know right now whether this will be a synchronous class, which means what we are doing right now, that we meet at a certain time, and or asynchronous, which is you have seen, which means record the lectures, just have office hours or something like that. So thanks for your feedback. I think you overwhelmingly told me that the live classes are better. And if you could do the same thing, which is put the PDF, record the lecture, and maybe put it in Canvas. So I'm going to figure that recording, that glitch I haven't been able to figure out because I have some cloud issues there. But that works, yeah? So I am just going to give my choice for the synchronous, for the model we are doing right now. So, Amir, that's something that you're going to get better at, and I want you to get better at. So, Anera, this was not a problem in your class, but in the other class, they tried to submit after the deadline of the test, meaning the test ended at 10:10 for your class, and people said, "Oh, I'm going to send you some other solutions by email." I mean, the ridiculous part was one student wanted to, after I graded the test, she says, "Oh, I forgot. Now I'm going to send you my solution." So that was just ridiculous. And that's why I just meant no submissions after. So, I mean, what I'm trying to say is you have this run. And what I'm trying to say to you is this is going to happen in fall again, Amir. So get that down, which means 60 minutes for the exam, 10 minutes for the upload, and we're going to go from there. Which we need to. Right, Nera, that's what we did. The last time you couldn't do it because we used responders, which was your lab lockdown browser. So if you looked at the instructions, I said no responders this time. And Amir, that answers your question as well. So you should be able to switch in on the same desktop. It will let you open another tab. So what I would suggest for all of you is, when I say 60 minutes Wednesday, stop the test. Stop the test. The Zoom is on because you can use your desktop camera. Or if you're using the phone to log in into Zoom, just let me know. Of course, I'll not see you, but I will see your submissions coming in. So you're going to take the pictures. I think I mentioned this, but I'm going to spend a couple of minutes on this. So take the pictures on your phone, email them to yourself. That's what I found the best way to do. When you download these images, you can download them as PDF. And once you have that, you can start uploading in Canvas. Does that make sense?
Yeah.
And Trent, yes, tomorrow's test covers the limit comparison test. And don't worry, Amir, I'm not going to I know 10:10 your test ends, so I'm going to give you a 5 minute plus 5 to 7 minutes after, but it has to be done by at least 10:15, 10:20. So you can't go beyond that.
So It's a little bit tangential, but for the final, is that still happening on some random day, not one of our usual meeting days, or has that not been decided yet?
I think, no, if you look at the SJSU website and you go to the final schedule, you look up your class. I think I mentioned it in my green sheet, but I have to go back and look. It's on Saturday. You were told this at the beginning of the semester, which was a Saturday final, and it was a common final.
That's what I recalled. I just wasn't 100% sure if it had changed.
That stays. The dean wants us to do it that way.
All right.
So in some ways, I think it's good because if you're sharing this with other people in your family, then at least Saturday is, a non-hectic day, so to speak. Not everybody is rushing for that computer or something.
I just need to get the day off work.
Oh, geez. Okay. So, yeah. Oh, yes, Jezebel, you do. Yeah. So if you're taking 2 calculus classes, in fact, I think if whoever is taking 30, which is Calc 1, there's a clash between 30 and 42, and the chair is going to take care of that. Oh, it's the same Saturday, yes. Yes. And it is on the website. And Cecilia, I'm talking to you. Yeah. Ready? Okay, here we go. So, no questions? If you want, don't ask them now. I'm going to hang around as we always do after the class, and we're going to do it. But next time, yes, you are going to have that test. So, having said that, here we go. I'm going to run this by you. So again, we start. What is series? It's an infinite sum. What are you adding? Or you're adding some terms. So therefore, we write this as n equals 1 to infinity an, which is a1 plus a2 plus a3. What do we want to know? We want to know if this is a finite quantity. If this is plus or minus infinity or does not exist, then it diverges. We are not interested. If it is finite, then it converges. Then we want to find the sum. So I'm going to write this in very sort of shorthand right now. So what is the first way to do it? Oh, get Sn, take limit as n approaches infinity of Sn. As I do this, I'm going to ask you, so tell me, when do we find Sn? When can we find Sn? And you can unmute yourself and say or type. And what is Sn? Sn is a1 plus a2 plus a3 plus am, right? So my question to you is, when can we find this? And the answer would be?
You, as I recall, said it's very difficult, if not impossible, to find that.
Right, but there is one case where you can still find it. And what kind of series should that be? Very good. The series is geometric, but I'm going to have you recall, William, that if it is geometric, we sort of skip this step and we go to the final step, which is we know that this infinite sum is a over 1 minus r. But you are right. What is the other kind of series where you can find Sn? Sadhana, P series is this series, which we said converges for p greater than 1 and it diverges for p less than or equal to 1. Where does this come from? Oh, this comes from the improper integrals. And Jezebel, there you go. Tell it.
Bless you.
Thank you.
Because what happens in telescoping is that you can cancel out the terms. Now, here is where I'm going to come and I'm going to start destroying one thing after the other. So what did we say about telescoping? It's got to be partial fractions, isn't it? That was the connection I made with the material that you've done earlier, which is still true. It is partial fractions. But here is a series I'm making right now. So tell me, what about this one? Is this a telescoping series?
Before we get too far, can I ask one thing about geometric series?
Sure.
Can you refresh my memory as far as what R is?
It's
R's.
Yeah, go on.
Is that the value that it increases each time?
It is the common ratio, Russell. Pay attention to the words. Ratio, that means you're taking a quotient. You're dividing.
Right.
And what are you dividing? You're dividing the next over the previous. If you don't want to remember it that way, then say ratio is A2 over A1, A4 over A3, A100 over A99. They all should be the same.
And that would be equal to R then.
Correct. And it
All
is the value of the R that tells you that.
Thank you.
Cecily, I don't understand your question. What do you mean by what happened to the harmonic series? Harmonic series lives right here. So little. Oh yes, this is given. I mean, you know, once you have a series like that, then you are just going to use it. But I know this is a P series because I know it in many different ways. I know a different form of the P series, which is the improper integrals. So I don't know, Cecily, if it was you or Jezebel who was talking about discrete math. If I remember correctly, it was you. So I'm just going to say this is your discrete math. And this is calculus. And there is your connection, since you've done discrete math. Does that make sense? Because here you're just adding for your harmonic series, you're just adding 1 plus half plus a third. What about the numbers in between? You're not even concerned. When you're talking about integral 1 to infinity 1 over x dx, this is a continuous function. Does that answer your question, Cecily? Oh, okay. Yeah. So my question to you is, what about this one? I want you to look at it and tell me, is this telescoping? And I want you to think of what telescoping means. So Jezebel, you said that telescoping. So tell me what telescoping means to you. And you can unmute yourself or type. So I think she might not be able to respond to. Very good, just about the terms cancel each other out. So tell me, does this look like telescoping to you? Very good. And how would you know that? And that is why we write it out. Because I'm going to exactly write it out. For n equals 1, it's 1 over e minus 1 over e squared. n equals 2 is 1 over e squared minus 1 over e cubed. Plus, I'm supposed to add n terms, isn't it? So the last one would be this one. And say, will that cancel out? So do this for me and tell me what will Sn be. If you have any question at this point, say it. So I want everybody to work on it and tell me what Sn will be. And go ahead and finish this and tell me if it's convergent or divergent.
Isn't there an issue because it becomes negative?
I don't know. Does it matter? Because, you know, this gets cancelled, right? That's the first thing.
Right.
And so tell me, Sn will be what?
Well, if we do 1 over e minus 1 over e squared, we get negative 1 over e. Or am I incorrect there?
You might be correct with the quantity there, but I'm not interested in the quantity because I'm interested in the sum of those n terms. I'm not interested in each particular sum here. I'm interested in the sum of first n terms. So if I write it out, I notice that these get cancelled. So the next one, Russell, is going to be this one, right? So they get cancelled.
Oh, I think I'm thinking of this the wrong way.
Doesn't it just... Now, it's going to be 1 over e minus 1 over e to the n plus 1. And that is going to be the sum of first n terms because terms cancel out. So my point to you was, this is not partial fractions. But what is the basis of telescoping series? That the terms cancel out. Once you get Sn, what do you do with it? You take limit as n approaches infinity of Sn. Can you tell me what that limit will be? Very good, Sadhna. That's going to be 1 over e. And why? Because this is going to be 0. This quantity is going to be 0. So current, yeah, there you go. So I'm just hoping that you were referring to just this quantity and you forgot this one. So what about this series? Converges or diverges then?
Converges.
There you go. More importantly, because it's telescoping, what is the sum of this series? You are saying, oh, this series adds up to 1 over e. And that, Russell, is not a negative number. So this is the sum of the series. Are we okay there? So I'm just going to continue. I'm going to remind you, you have the test of divergence. But it fails if limit is 0. Then you have the integral test. But that only works for positive. Plus, f must be integrable. Meaning you should know how to integrate that one. So you moved on to comparison and limit comparison test. Latch on to the key words. The key word here is comparison. So you are comparing two series. I'm talking about comparison now. So you're comparing two series. And you're using what? You are using the connection, the comparison theorem from improper integrals. For limit comparison, yes, you are taking the limit of an over bn. And if this limit is a finite number, which is greater than 0, then both converge or both diverge. So I'm going to take questions after I finish this. So if bn, so how do you come up with bn? The most simple rule that will work for your class is going to be the highest power in the numerator, the highest term, or power in the numerator over the highest term in the denominator. I really don't like this. I've used this because your book uses it, but I'm just going to say Bn is the dominant power, the dominant term. What do I mean by dominant term? You're taking n approaches infinity. So we just want to make Bn the dominant term in what? In the given series, an. So dominant power in the numerator of an and dominant power in the denominator of an, because, and this is what I'm going to say, that if an is n cubed plus 2 over n squared plus 2, and you are going to look at the behavior as n approaches infinity, then tell me, who is the dominant power here? And I'm just going to put, so in the numerator, who is the dominant power then? Meaning when n approaches infinity, this is going to go to infinity faster than this one. Very good, Sadhna. In the denominator, this is going to go faster to infinity than this one. So these are the dominant powers. So my Bn is going to be n cubed over n squared, which is n. And as this one goes, your series goes. Are we okay now? Are we okay now? So I'm going to take Karan's question. Yes, Karan. And that was the point I was trying to make, that this is not partial fractions. But then you can still find Sn, because telescoping is that Pirates of the Caribbean, when you kind of have that telescope sort of looking at the land, once you've spotted land, you can bring it back in, which is you bringing it back in, and bringing it back in is terms cancelling your S and shrinking. So that telescope shrinks and you put it in your pocket, and that is telescoping series. So I'm going to pause here. So any questions there? I'm just going to finish with this. So when do I use limit comparison? When comparison doesn't work, but this doesn't change. Bn is still selected that way. I'll be okay then. Which means we have to go to the next bit. So just letting you know that comparison and limit comparison. Sorry, limit comparison. And integral tests. They are for positive terms only. So you can use this on a series of positive terms only. So here is the next idea then. What about an alternating series? What does that even mean? It means terms alternate in sign. Meaning one is positive, one is negative. What are the examples? What does such a series looks like? So I'm going to give you two actually. So here's example one. And here is example two. Okay, let me just make this. Sadhna, will somebody respond to Sadhna's question? Is alternating series on the test? Sadhna, I've never done that. I've never done a material in, just right before the day, just give you one day to digest it and then ask you like that. No, I've not done. So if you look at thing, I have changed it. Didn't I put up a study guide?
Yes, I believe you did send one out.
Okay. Sadhna, I think it's not your day today. So again, people answer her question.
Yes, it will be on the final.
Sadhna, so I think you're just waking up, right? It's not just this section. We have, what section are we on? 11.5. We have 4 more sections to go, Sadhna. I know where this is coming from. You want it to end, but you will have to live till the end.
If they give you the option, we'll take like stuff off the final. They don't keep it on for our account.
See, it's not that now, because there are too many things that happened. So the department wanted to have a common final. The common final was that when you go into 32, the idea was to get an idea of how our students are prepared. Once you give them the common final, the common topics, then you can track. It's easy to track rather than having instructors do their own final. So that is why we implemented that at the beginning of this semester. Nobody anticipated that the semester would turn out like that. But then at least to achieve something from there, especially if fall is going to be online, then the decision was, let's stick with that common final. And so answering your question, to take the sections off or not is not up to us.
I was joking.
No, but at the same time, I'm slowed down. I'm sure the other instructors are as well. So we've been having continuous meetings. So we are going to have, probably we won't be able to finish as much as we can this semester. So we will give you a topic list of what's going to be on the final. But we have to do 4 more sections. So maybe you will be taught them, but they won't be on the final, but this one will be there for sure. Ready? So here we go. So write those terms out then and tell me what this series looks like. So it's going to be what? -1 to the 0 times 1 plus -1 to the, and this is n equals 1, n equals 2. This is going to be -1 times 2 plus -1 cubed times 3 plus -1 to the 4 times 4, and so on and so forth. So this is going to be -1 to the 0 is 1, so that's going to be just 1 minus 2, and this is going to be what? Did I mess up? Yes, I did. This should have been a square. This should have been this. And so this is going to be +3 minus 4 plus 5. You get the idea. The terms alternate in sign. What about this one? And this one is going to be -1 to the 1, 1 over square root of 1, plus -1 squared, 1 over square root of 2, plus -1 cubed, 1 over square root of 3, and so on and so forth. So this alternates in sign as well. Sorry. So does the first one has to be negative, positive? I don't care. It just has to alternate in sign. So the question is, when they're alternating in sign, meaning what? If you're talking about, at this point, I just have got to ask, are all of you paying attention, or some of you are still writing? Because again, I want to build this very conceptually. And Aaron, that's a yes for paying attention, or you're still writing? So go ahead and indicate to me. Okay. Okay, Cecilia, you're still writing. Okay, sure. Take your time. Okay, and how about the others? Trent is not talking to me today. Nara, Trent, Lucas. Is Lucas here today? Sam. Okay, Bhavneet is ready. Long has stopped talking to me after we went online. Oh, there you go. Thank you, William. Almari. Is Long not here today? Anyway. I think we have 27 people. We should be okay. That's a healthy number. So ready for this one then. So pause, throw everything out. So what's the problem here? That's how can we tell a series converges or diverges? We look at the sum of n terms. What is your problem now? The problem is this. If I take sum of first term, it is just 1. If I take sum of first 2 terms, it's -1. If I take sum of first 3 terms, then it is going to be what? 2. If I take sum of first 4 terms, then it seems to be 5 and 6, and then it's going to be -1 again. So your sums, they seem to be going up and then going down and then going up and then going down, and there seems to be no regular pattern to it. And so we have to think of it in a different way. Just because you are adding and subtracting different amounts, Sn is a bit difficult. So tell me then, and I'm just going to, as I said, build this off of you. So here is one of the things that we do, and I'm going to go with example number 1, which was 1 minus 2 plus 3 minus 4 plus 5 minus 6, and so on and so forth. So you're looking at this one, and the idea here is when we do it alternating series, and I'm just going to start writing this. This is called the alternating series test, and I just want to, as I said, build this conceptually, meaning we're going to look at the test and we're going to see why it works. So here is the alternating series test. So first, they're saying you have -1 to the n minus 1. By the way, I'm trying to write this as your book is writing it. This is how an alternating series test looks like. Which is what? You have B1 minus B2 plus B3 minus B4, and so on and so forth. So, to use the alternating series test, you have to verify these two things. And they're saying each Bn is greater than 0. So first, and this is the way I write it, first separate the Bn's. So separate. Or if you want to say, you can say identify Bn. Number 2, make sure that this Bn is a decreasing sequence. Number 3, the limit as n approaches infinity of Bn. If this is 0, then the series converges. By alternating series test. So let's look at both the examples that I have put up. Please do not write them. Let's start here. So this was my first example. I'm going to erase and I'm going to, so this was my first example. So tell me, from what I wrote down there, what would be Bn? So I'm just going to say, and I'm going to bring it up here. So isn't this, this is what I wrote in the definition, isn't it? So can you identify what Bn is here? Bn is very good. N. Is that positive? Yes, these are your Bn's, isn't it? That means what are you saying? Exactly what I wrote. You're separating. Separating what? You're saying, let's forget the signs. Let's forget the alternating part. Let's just look at the terms. I know you're adding one, you're subtracting one, you're adding one, you're subtracting one. That seems to be the pattern. But right now, just separate them. Look at this one. So here, what would be Bn here?
1 over the square root of n.
Thank you, sir. So Bn is 1 over square root of n. Again, the idea is, forget the signs, just look at the terms. So we are just going to look at these terms. These are your Bn's. Now what does it say? Now let's go to the series. So it says Bn must be a decreasing sequence. So let's try to visualize this. So you are saying those Bn's that you separated, which we're going to forget right now whether you're adding or subtracting, but these numbers, these Bn, which are all positive, are going down. In other words, B1, what do we mean by decreasing sequence? Can I say B2 is less than B1, B3 is less than B2, B4 is less than B3, and so on and so forth. So I'm just going to say that when you say it's a decreasing sequence, the next term, the next Bn that comes, is always less than the previous one. Okay? Next, what are we saying? If you look eventually, what happens? They're already decreasing, but eventually what happens? They just go to 0. So that means what? When you are looking at the sum of this series, eventually, what quantity are you adding or subtracting? So what does this mean? That after a certain time, I don't care whether you're adding or subtracting, but what quantity are you adding or subtracting? What does it mean by that? You're adding or subtracting what? Negligible amount, isn't it? It's almost 0. So then will you get a finite sum in that case? And the answer should be?
Yes.
Thank you, Russell. And that is the alternating series test. So the idea is, if it is not a decreasing sequence, then no, you can't apply that. And the question is, what do I do in that case? But before I do that, I wanted to prove the alternating series test to you, or rather see how it applies here. So here is what I'm going to do. I'm going to take that example number 2. Which was -1 to the n minus 1, 1 over square root of n. What did I say? N goes from 1 to infinity? I'm just going to look up what I wrote there. There. Okay. This can be written this way as well. So let's just go. So this is going to be -1 to the 0, 1 over square root of 1 plus -1 to the 1 over square root of 2 plus -1 to the cube squared, 1 over square root of 3, and so on and so forth. So if I have to write it, then it is 1 minus 1 over square root of 2 plus 1 over square root of 3, and so on and so forth. This should be a minus. So start this one for me. Identify Bn. I think we have done that. So I'm going to go Bn is 1 over square root of n. Because n is greater than or equal to 1, this Bn is greater than 0. We come to the next part. We want to prove it's a decreasing sequence. How do you do that? We're going to take the derivative. So we are going to look at the corresponding function, which is x to the -12. What is the derivative here?
-1/2 x to the -3/2.
Very good. Because x is greater than or equal to 1, we could write this as -1 over 2 x to the 3/2, which is always going to be negative. So this is a decreasing sequence. What does it mean? Oh, your terms are getting smaller and smaller. The terms that you're trying to add or subtract are getting smaller. So tell me, the terms are getting smaller and smaller, and this is supposed to add to a finite number, then eventually they should get how small?
Numbers approaching 0.
Very good. Because if they are not numbers approaching 0, that means what? You're still adding and subtracting some finite quantity, isn't it? And that's not going to lead you to a finite sum. Because you're saying, as I start adding these numbers, there comes a point, I don't know what point it is, but comes a point that after that, when I start adding the terms, they're negligible. They're 0. So however many terms are added here, this sum stays. Does that make sense? And that is why it converges. So here we go. So we're going to go there. So the next part we have to say is 1 over square root of m, that is indeed 0. And so you're going to say by alternating series test, the series converges.
So I'll ask the question that's on all of our minds. How
Go
much of
on.
that work do we actually need to show on the test?
All of it, because you have to. Did I put the convergent test series PDF? Did I put that, or I forgot? Anyway, I'm going to put that today so you can have it with you. But I told you to write these. So these conditions, Russell, that exactly the way I worked it, that identify BN, decreasing sequence, the limit. If the limit is equal to 0, you're done. It converges. The question should be, what if one of these fails? What do I do then? And that is why example 1 that's coming up. But I'm going to pause here. Any questions? So the 3 blue arrows you see are the 3 things you're going to do for me when you do the alternating series test.
All right.
Okay? Let me take another example before I go into what happens when it fails and all of that. So here it is. Here's my next example. And let's practice that test for a while. So it's n equals 1 to infinity. Negative 1 to the n plus 1 over, n minus 1 over ln of n plus 4. So, teaching to the test now, number 1, you're going to write it out. And this goes for tomorrow's test as well. Whenever it's series, the first part I will give you credit for is when you write it out, which means you're going to say, okay, this is negative 1 to the 0, ln of 5, plus negative 1 to the 2. So this is n equals 1, n equals 2. So this is 1 actually, over ln of 6. N equals 3, so this is negative 1 squared, ln of 7. And just because I don't have space, but you can write more terms if you like. So here we go. So this is 1 over ln 5 minus 1 over ln 6 plus 1 over ln 7. You know what's coming next. 1 over ln 8 plus 1 over ln 9, and so on and so forth. So you're going to observe terms alternating sign. So that's an alternating series. And this is kind of easy. So because when terms alternate in signs and alternating series, you don't have to go through the list. There's only one test to go after, which is the alternating series test. No mystery there. Terms alternating sign, use the alternating series test. This is as about easy as it can get, correct? And Bn then, Russell, first. So Bn is
1 over ln of n.
plus 4.
Oh, right.
Right, so what is the first thing that you have to do? You have to say that this is positive, and you're going to say, look, it is, because n is greater than or equal to 1, all these Bn terms are positive. Don't write it. That's why we have math notation. So you're saying n is greater than or equal to 1, so this is the reason, that's why this is the justification. So this is what you're trying to say, and this is the reason for it. Once you have that, then we want to show that Bn is decreasing. At this point, I want everybody to stop writing. And this is what I've seen happen through the years on the test, because you try to take shortcuts. Because you are saying, look, isn't ln of 6 greater than ln of 5? So 1 over ln 6 is less than, well, this term is less than this one. This term is less than this one. So that's it. I'm done, because this is a decreasing sequence. Why do I have to find the derivative? And I think I have cracked this joke before, but that is the joke that goes for, I do that in discrete math as well, induction. And I'm talking to you, Jessica, because what does induction prove? It is for all, right? even the unseen terms here, the terms that you do not write, you are saying, if you follow this dot, you will see the same pattern. What pattern? That the terms are decreasing. So is everybody ready for a bad joke? Here it goes. So I'm just looking at Trent right now. So Trent is handsome. Trent's dad is handsome. I've done this joke before. So Trent, and that is not a joke. Trent is a handsome kid. So Trent is handsome. Trent's dad is handsome. Trent's grandpa is handsome. So you can't just look at Trent's grandpa's picture, Trent's dad's picture, Trent's picture, and say everybody that comes in line after Trent in the Tatko family is, or Tanko family rather, is going to be handsome. So how do you justify that? What if Trent's grandchildren ends up marrying somebody who's utterly ugly? Sorry, Trent. So how do you justify that gene, that handsome gene, is going to overpower no matter whose Trent's grandchildren marry? And how do you do that? You do that for, oh, shut up, Karan. There's nothing like inner beauty. There's an inner beauty, but there is an exterior beauty. So how do we do that? BN is decreasing. So X-rays never look beautiful, Karan. So to show that BN is decreasing, you are going to take the derivative. So, oh, there is Russell. Don't make me go there. You're going to wait. We're going to waste our time. So to show that BN is decreasing, what do? We're going to take the derivative. So we're going to take f of x is ln of x plus 4 to the negative 1. Let's finish these problems and let's do more bad jokes. So f prime x would be what? Negative 1 right?
Yes.
So this is negative 1 these are the things I'm looking for. So do not go wrong in the derivative. You're going to say x is always greater than or equal to 1. So this is negative, meaning the derivative is negative. So Bn is a decreasing sequence.
Actually,
so we have shown, go on.
One question. I said yes about the derivative, and now I'm second guessing myself. You're doing the chain rule, right?
Correct.
Wouldn't that be, oh, never mind.
Okay.
I see it. Yeah. 1 over x plus 4 is the derivative of ln of x plus 4.
Correct.
Though.
Correct.
But wouldn't the chain rule say that it's the derivative of x plus 4, not ln x plus 4? So you'd have 1 over x plus 4 multiplied by something?
Multiplied by what? You're right. Technically, you're right, but multiplied by what?
By 1.
There we go. So if you want me to write it, then here it goes. Times 1. You're absolutely right.
Right, but why is there... Oh, because it's raised to the negative 1.
Yeah. Because it was, your Bn was this, see? And so the corresponding function would be... And I just wrote it because it's easy for me to check the derivative.
Right. Okay.
Jezebel, it's open notes. So, and Jezebel has a very interesting point, and that is what I'm trying to say to you people, that take advantage of the situation, that you know what your strengths and weaknesses are. So if you want to have derivative formulas in front of you when you're taking this test or the final, go for it. Make a derivative, write the derivative formulas, keep it in front of you so you don't go wrong. You go. And so now you can make a customized cheat sheet, which is for yourself. So don't waste time rumbling through the notes, because that is what happened in my other class. They wasted time looking it up. No, you have to treat this test. I'm saying this really, really, because if you choose to take classes in fall, then now is the time to get your sort of armed for that battle. Because in fall, no excuses, none at all, because you have been exposed to this. So make a customized thing, say, study for this one as if it was an in-class test, but now you have a distinct advantage. Make a list of the things that you would want to see in front of you. So I would make those 3 pages. And then if I need to look up, I'll look up the notes. But otherwise, I'm going to work off these 3 pages. There you go, Cecily. That's one way to do it. But, when you're taking the test, you're flipping in between. You don't realize how much time is wasted. It's just like that juice example. You just bring that 16-ounce juice, the Jamba juice example. I'm almost haunted by that experience. But it's really that. And even I didn't realize. I didn't get up on that day and said that I was going to time this kid who was going to bring Jamba juice. But I was so interested when she got that 16-ounce thing for a 15-minute test. You don't even realize when you're doing it how much time is spent in just drinking the liquid as opposed to, I'm not saying you stop thinking about the test, but your pen is not moving. Okay, so Bn is a decreasing sequence. So let's look at the last step then. So we take limit as n approaches infinity, 1 over ln of n plus 4. And we all agree that this is going to be 0, right? Why? Because at this point, I don't care. You can just say, oh, this is ln x. So as x goes to infinity, ln x goes to infinity. Remember, you're talking about x greater than or equal to 1 anyways. And so this is going to be 0. Once you have that, you're going to say, okay, by alternating series test, the series converges. So I'm going to have it there. And here we go. So I think you're talking about some kind of food, but I'm just going to say, first, thank you to Trent for being such a sport. So it was just, I was looking at the chat and yours was the first name that popped up. I was looking at it, so I just went with that example. Well, I mean it. The Tankos must be a handsome family. Any questions? But this is the alternating test. This is how it should go. This is how it should run. When I say run, again, I'm repeating myself. Identify Bn. Make sure they're all positive. Decreasing. Make sure the limit is equal to 0. If that happens, that's it. The series converges. The question should be, what happens if the limit is not 0? And that is what we're looking at it. And then more conceptual aspects of it. So what did we just do here? We said, forget your adding or subtracting. Forget the sign in front of it. Just look at the terms. And if the terms are positive, the next one that comes is less than the previous one. And eventually they grow so small that they are all 0. Then the series must be convergent. Oh, thank you, Trent. But this is the example, and I want questions before I move on, because when I move on to the next concept. So no questions there? We're okay? Each and every one of you?
The only thing I'm a little shaky on is still in the derivative, but I think I'll just go back and look up the derivative formulas for that one.
Right. I mean, in the book, if you have the book, you have the ebook anyway, so go back and just write down all the derivative formulas for you. But see, I think...
I'm just getting confused with the chain rule. I can't tell if that's 2 or 3 functions is all.
So, I don't know what the kids are talking about. So I'm just going to keep talking to you because Cecilia and Karan are fighting over something. But anyway, I'm just going to say to you, remember last semester we talked about it. There are formulas and there are techniques. So in this derivative, it was a combination of both. The formula part was that ln of x plus 4, the formula is, it is 1 over x plus 4. But the move that we made of multiplying these 3 terms is the chain rule. So there was a technique aspect of it and there's a formula aspect of it. So go ahead between today and Wednesday. Just keep derivatives ready. You need for integral test anyways.
Right. Right. So this is the chain rule, and there's 3 parts, which is x raised to the -1, ln of x, and x plus 4.
Correct.
That's what was confusing.
The chain rule, remember we talked about this last semester. When do we use the chain rule? When it's composition of functions, right? So I can think of this as f composed of g composed of h of x. And then you can say this is h of x. G is the ln function, and f is the negative one.
Right. I
And
was
then
only
you do
seeing
it.
G and H.
And so I'm just going to say that when you do the chain rule, what do you start? Chain rule, you start from outside to the inside, meaning you differentiate this function first. Do not touch the inside. Remember the junk joke we are going? Yeah. So you just need to revisit that one.
All right. Thank you.
No worries. Yeah, and Ami, you're right. That is the U part of it. Yeah. So chain rule U sub, that's what we talked about. That is from there. So ready for the next example then. So no questions about this one, but these are the three things that you have to do. And conceptually, I want to write this again. So what is this alternating test about? Yes, you are adding and then subtracting terms. So the idea is, forget these two, just look at the terms. That is your BNs. Check if they're all positive. Next, check if they're decreasing. And what does it mean? They're getting smaller and smaller. And now understand the concept. So yes, they're getting smaller and smaller. But if I told you they get smaller and smaller, but you know what? They only get smaller and smaller and all of them seem to converge to half. That means what? Eventually, you are adding or subtracting what? You're adding half, you're subtracting half, you're adding half, you're subtracting half. So there is no stoppage there because you have some terms and eventually this quantity is being added and subtracted and added and subtracted. So there may or may not be a finite number. But when can we guarantee a finite number? Or we can guarantee a finite number if they're getting smaller and smaller. But eventually, so here's the next check. Remember, they're already getting smaller and smaller, but limit as n approaches infinity of these bn's are 0, then voila, the series converges. So let's talk about she smiled now. So when does she smile? Oh, when this falls apart, when it's not decreasing, or it is decreasing, but the limit is not 0. She smiles. If you don't like the joke, then you're going to say test fails. The question is what to do then.
So, wait, if the limit doesn't equal 0, then it's not divergent?
Oh, we will see. Here is where the first example comes. Here we go. This was what? N equals 1 to infinity. What did I write? The very first one. So -1 n minus 1. So here we go. Your intuitions are right, Russell. I just want you to get there mathematically. So start this one for me. First, is this an alternating series?
Yes, it is.
Very good. So it's yes. So if it is alternating series, you start applying the alternating series test. So Bn is what?
N.
So f of x is x. What is the derivative? The derivative is what?
1.
Very good. Which is what? Positive. And what does positive derivative say? F must be increasing. So I'm just going to say Bn is increasing. They were positive, all right. So I'm just going to write here Bn equals n greater than or equal to 1. Bn is positive. But Bn turned out to be an increasing sequence. That means alternating series test fails. And now I want everybody to stop writing and now go back. Meaning what? Go back to the test you know. So can you use comparison, limit comparison, or integral? So can you use any of these three tests? And what am I talking about? I'm talking about the original series on this one now, because you tried alternating series test, it failed you. So can you use any of these three? And remember, I'm not talking about the B and all that now. That was part of alternating series test. I'm talking about this one, which was what? Which is 1 minus 2 plus 3 minus 4, and so on and so forth. So can I talk about these three tests? And the answer is no, because all the terms need to be positive. In other words, you should always be adding all the time, because this was positive terms. And so geometric and everything is out, because we know this is not geometric. It's not telescoping, nothing is cancelling that. So what's left, people? What is the one test that's left? And that would be what? The simplest test, which is the test of divergence. That is still left. I can use it. And so what does the test of divergence do? There you go, Amir, that was good. So it says limit as n approaches infinity, -1 to the n minus 1 of n. Because remember, test of divergence is the limit of this. So tell me, what is the limit of this one? As n approaches infinity, what is this limit? Very good, Amir. Does not exist. And why? Very good. Infinity and negative infinity, because you are going to say, okay, if n is even, then the limit is negative infinity. If n is odd number, then the limit turns out to be positive infinity. So the limit goes between positive infinity and negative infinity. So the limit does not exist. And what did test of divergence say? If the limit is not 0 or it does not exist, then the series diverges. So this series diverges. By what? By t of d, as Amir writes it. Test of divergence. So my point being, when the alternate test series fails, who do you turn to? Why not the others? Because they don't apply. Are we okay now? So I'm going to go to the next one. Here we go. So here's another example for you. So this is summation n equals 1 to infinity, -1 to the n minus 1, tan inverse of n. We have done this before, but I want to do this again. And here we go. So number 1, write it out. And Karan, it is divergent, because that's what test of divergence says. If the limit is not equal to 0 or does not exist, test of divergence says that it diverges. So start writing this one for me. So this one is going to be what? Minus tan inverse 2 plus tan inverse 3, right? So identify Bn for me.
Tan inverse of n.
Very good. And n is greater than or equal to 1, so Bn is greater than 0, right? So the next part is we have to show that it's a decreasing sequence. So the corresponding function would be tan inverse x. And the derivative of tan inverse x is?
1 over 1 plus x squared.
There you go. You do remember that. So this is what? Positive. So Bn is an increasing sequence. It's not a decreasing sequence. This is the algebra work. This is the paperwork. You can also identify, you have a calculator. So if you graph tan inverse of n, you know it goes like that. You know the limit is pi over 2, don't you? You should remember that. So this is an increasing function. It's not a decreasing function. It increases slowly, but it still increases. So alternate test fails. Translation, I cannot apply it. So I'm going to look for what? I'm going to look for limit as n approaches infinity, negative 1 to the n minus 1, tan inverse n. And tell me, what is this limit going to be? And so this limit is going to be?
Is it also the, well, no matter what that first term is, it's always going to be 1, either positive or negative. So doesn't it just depend on tan inverse of n?
So why do you say this is always going to be 1? Because I could argue with you. See, n is approaching infinity, right? So you are talking about eternity. You're talking about numbers that are what? Let's think about CEO's salaries on Wall Street, something like that. That huge of a number. So you're talking about, or maybe the PPP package that they're rolling out now. Well, it's at 2 trillion now. So look at that number. That is what we are talking about. N approaches infinity.
Right,
so
but
if it's 2 trillion, then 2 trillion minus 1 is going to be an odd number, isn't it? So it's going to be negative.
Right.
If it is 2.1 trillion or something like that, then, you know, it's an odd number. So this part is going to give you a positive sign. Limit as n approaches infinity of tan inverse n, that is a sure pi over 2. The pi over 2 is going to be multiplied by either negative or positive. And no, Amir, it can't be infinity because you're looking at this tan inverse n, and what happens as n approaches infinity? It doesn't go infinity. It's kind of, it approaches this line pi over 2, and we have talked about it. So this time you're going to say the limit is plus or minus pi over 2, which means what? It just oscillates between the two numbers, isn't it? Either it's positive pi over 2 or negative pi over 2. So we can say the limit does not exist. And so by test of divergence, the series diverges. So here is the next idea then. Okay, alternating series can do more. So if the series converges, so by AST, if the series converges, can we find its sum? And the answer is no, but we can estimate its sum. And that's going to be our next time. But before we go there, I just want you to look at this picture. So I want everybody to stop writing. And I'm going to talk about this alternating series. So let's look at alternating series. And let's look at what this series is. Oh, it's A1 minus A2 plus A3 minus A4, and so on and so forth, right? So everybody please stop writing. If this series converges, this is a big if, I'm saying if this series converges, then what should happen? Oh, these are all decreasing, which means what? A2 is smaller than A1, A3 is smaller than A2, and so on and so forth. And eventually, we have another thing, that limit as n approaches infinity, an is 0. When these two things happen, that alternating series converges. So completely stop writing, everybody, now, and here we go. So remember, what is S1? A1. What is S2? Sum of first two terms, so that is A1 minus A2. What is S3? A1 minus A2 plus A3. What I'm trying to show to you in pictures is why this works. So let's start. And remember, what is the basics of series? You always look at Sn and you take limit as n approaches infinity of Sn. So I just want to show you in a different way. And as I said, completely stop writing and look at this one. So can I say this is S1 from here to here? Which is what? This is A1. Whatever the term is, if I stretch it out, it goes from here to here. This is the length of A1. So let me say to you, this is the positive direction, and this direction is the negative direction. So this is the positive, this is the negative. So what would be S2? So I'm saying S2 is A1 minus A2. That means I'm going to start here. I'm going to come back. Do I cross this barrier? No. Why? Because A2 is smaller than A1. So I'm just going to say this is S2. Now what do I do? For S3, to this A1 minus A2, I'm just going to add A3. But this A3 is smaller than A2, so it's going to be this way. So this is S3. And I hope you get the idea. And I'm going to say again, the next term, I'm supposed to subtract A4. But A4 is smaller than A3. So I can't go beyond this, meaning the sum is not going to go beyond. The sum is going to be less than S3. So this sum is going to be here. So this is S4. Now what? I'm going to add A5 to it. But again, this sum cannot be greater than this one because A5 is a smaller number. So this is going to be, and it is going to be. And eventually what happens? You subtract or you add. Eventually, it's going to go to 0, isn't it? So eventually, you reach a top somewhere where it's going to be a finite number. Are we okay with this?
Yep.
So I'm kind of going to stop here. I think what I've done is I have made today's homework to, I don't remember now. Probably must have made it due Wednesday midnight. Do that after the test if you like. And if it means you can't get some problems, just email me. Should we just keep it at that? I have no idea what I've done. See, this week. So these are my office hours.